to another fundamental experiment in the history of science. We have Ernest Rutherford's gold foil experiment. So, if you guys have taken like a chemistry class in grade 11, grade 12, you might have heard of the gold foil experiment, which basically sort of proves that the atom is not the smallest part of the universe, is not the fundamental piece of nature. Because originally, when atoms were, thought of or devised, like the meaning of atom in Greek means indivisible. It means uncuttable or something like that, right?
Which is false.
So, sorry?
Which is false.
Oh, of course. Like the statement is false, but
Yeah.
the atom means indivisible.
Yeah.
And Rutherford was like, well, no, I don't think so. I think the atom has a central part to it with things flying around, right? With these negative charges flying around, basically. So his idea was to send positively charged particles, so basically just the nucleus. Again, in that time, they didn't even know the nucleus existed. So they just charged, I guess, a particle and they sent it through. The point being that there was a gold foil that was simply straight in front of that laser, let's say. And there was a screen all around that gold foil, nearly 360 degrees all around that gold foil, kind of like almost like like circulating it almost, except for that, obviously, that one slit where the laser can come in from.
Mm-hmm.
I mean, again, it's not actually a laser. Laser is the wrong word for it, but I'm just using it because a lot of people can understand, like, oh, it's okay, it's a light beam, right? So it's like charged particles, basically. It's not even light, really. So the idea is that if an atom is an indivisible element, then then all of the particles from the charged beam would pass through the gold and end up in the same spot.
Actually, that's not the reason. Like you said if the atom is indivisible, then it would actually just pass through. But the actual reason is because before this experiment, they thought that atoms were like plum puddings, right? They were like positively
the plum pudding
charged.
model. Yeah.
Or like positively charged particles inside of like a negatively charged pudding type deal, or maybe it was the opposite, like a positively charged pudding with negatively charged particles inside of it. But anyways, the point was that these packets were neutral because it was positive and negative. They would just cancel each other out and everything would be neutral. So if you were to send positive particles through the gold foil, there would just be no electromagnetic interaction whatsoever because everything is neutral, so it would just pass straight through. But what they saw was that there was deflection, reflection of these particles, which actually was proof that it's not these neutral packets, but they're separated in positive and negative, and that these positive particles would sometimes come close to the nucleus, which would then you would have an electromagnetic interaction there, which could deflect, reflect, and deviate the paths of these particles.
So basically what they observed was that all of these particles of this beam were not all traveling in a straight line and appearing in the same place that where they left. Instead, they were all deflected around this circle. And the percentage and the amount, per 1,000, and basically understanding the percentages of where each would go is also obviously written up in a very concise manner. Not that I'm going to start spitting it out right now, but the idea is that there is a probability for for this alpha particle to go anywhere depending on what part of the nucleus it hits, where it hits, how it interacts. So many factors, so many factors. And again, the moral of this story, like the moral of this experiment, is that it kind of sort of proved or helped prove that the atom is not an indivisible element. It instead contains smaller subatomic particles, hence the name. And I believe first we only understood the nucleus and electrons before decomposing the nucleus into neutrons and protons.